First of all, I'm making this video while Simone is sleeping. So the reason I'm talking in these creepy hushed tones is because I don't want to wake her up. It's not because I'm trying to make you feel uncomfortable. Okay, 6.4, Linear Applications and Modeling. By now you know that the word application means word problems. But the good news is almost all the word problems in this section are identical or very close to each other. Alright, so Dana bought a car for $28,000. 5 years later, it was only worth $16,000. Graph the depreciation. You know what depreciation means? Depreciation means when something's cost, or its value goes down. Appreciation. I know there's two types of appreciation. There's the type you have for me for making these videos, but there's also the appreciation when something gets worth more over time. That could be something like a fine bottle of wine or something. Gets more expensive as time goes on. A car gets less expensive over time, unless it's like some kind of classic collector car or something like that. Okay, we're going to graph it. So these graphs can be very, very simple. We're going to graph the depreciation of the car over time. So down here, you always put time on the x-axis. And the time in this case is in years, right? It's not in months or days, it's in years. And over here we have value on the y-axis, and that's in dollars. And it says that she bought the car for $28,000. So what time is that when she bought it? That's time 0, right? She bought it and no time had elapsed yet. And the cost of the car at that point was $28,000. And then 5 years later, so now we go out to 5, you can just go as far as you want. You notice I'm not being accurate here or anything. We just want to use the graph to help us come up with the equation and stuff. We go out to 5, and it's only worth $16,000. So I don't know, I'll put 16,000 right here, and there's a point right here. At 5 years, it's worth $16,000. At 0 years, I guess I could put a 0 here. At 0 years, it's worth $28,000. So those are 2 points. And then what you're going to do is you're going to draw a line connecting them. And we're going to assume it continues in a linear fashion. So somewhere way out here, it's going to be worth nothing. Alright, there you go. Now, you don't actually even need to graph these things. If you want, you could just use the 2 points. So I'm just going to write the points here that we're dealing with. The 2 points we're dealing with there are 0, 28,000 and 5, what happened there? 5, 16,000. Okay, those are our 2 points. 2 points. And we're going to show you in a second how really you don't even need to graph it, you could just use those 2 points. Okay, what we're going to do is we're going to find an equation that models the value of the car over time. So we're going to find an equation that matches this line right here, matches this graph. And the way we're going to do it is we're going to use point slope form. Remember, point slope form is y minus y1 equals mx minus x1. And also recall that these two things don't go anywhere. We're going to still have a y and an x in our equation, but we need numbers in all these other spots. M's the slope, and xy, that's a point. Well, remember we have 2 points here, so we have a point. All we need to do is find the slope. Alright, to get the slope, there's 2 ways you could do it. One way you could find the slope is you could use our graph here, right? What we could do is we could draw one of those little triangles. So from this point to this point, we have to rise this much, and we have to run this much. Now, how much is that rise amount? That's from 28,000 to 16,000. That's 12,000. How much is this run amount? It's from 0 to 5. It's 5. So our slope is going to be 12,000 for rise. I'll put rise over run here. Our slope is equal to rise over run, which is 12,000 for a rise over a run of 5. And if you divide those, you get 2,400. Except for one thing. Look at this line here. This is a negative slope, so it'd be negative 2,400. That's our slope. Okay, there's another way you could get slope though. How do you get slope when you don't have the graph? If you only have 2 points, you do change in y over change in x. So we take our 2 y values, 28,000, subtract 16,000. Now be careful, if I did 28,000 take away 16,000, for my change in x, I have to do 0 take away 5. and that equals 12,000 over negative 5. And if you divide those, you get negative 2,400. You get exactly the same thing. So you can use the graph to do this if you want. You can use the 2 points to do this. Either way, you're going to get a slope of negative 2,400. Great. Now we're able to enter stuff into the equation here. So we put y. Now we need to use one of the points. Which one? You can use either one you want. Do you know which one's easier? This one. How come? Well, there's 2 reasons. One reason it's easier is because that 0 there. It's always nice to deal with zeros. The other reason is this point is right here. And what very important point is that? That's the y-intercept. And we know that's going to be part of the equation when we switch it to slope-intercept. So let's use that equation, that point right there, sorry. So y, take away the y value, which is 28,000, equals the slope, which we now know is negative 2,400, times x, is still there. Take away the x value, which is just 0. There's point-slope form. Let's change it into slope-intercept form. I think we can do it in one step. Y equals, we want to isolate the y. You're going to do mountains here, expand. So negative 2,400 times x is negative 2,400x. And negative 2,400 times 0 is just 0. You don't even need to write it. And then in order to isolate the y, we have to move the 28,000 over, and it becomes plus 28,000. There you go. There's our equation. One last thing. If you want, instead of using y's and x's, you could use some other letters that are more representative of what we're talking about. So we're not really talking about y's here. We're talking about value. So why don't we put v instead of y, v for value, equals negative 2,400. Instead of x, why don't we put t for time, plus 28,000. You don't need to do this, but it might be easier when you answer the next set of questions below here. Okay, there's our equation. By the way, what is this negative 2,400, this negative 2,400? What does this mean? Well, remember, it's rise over run. Rise was value, dollars, and run was time, years, dollars per year. This is negative $2,400 per year. That's how much the car depreciates every year, negative $2,400 each year. All right. Remember, slope is a rate of change, and this is the rate that it's changing. It's changing at negative $2,400 per year. How much will the car be worth? How much was the car be worth? How much will the car be worth? Or how much was the car worth? Let's do this. How much was the car worth after 3 years? So 3 years, is that a value or is that a time? That's a time. Just put 3 in where the t is. V equals negative 2,400 times 3 plus 28,000. Sorry about that. V equals negative 2,400 times 3 is negative 7,200 plus 28,000. If you combine these, negative 7,200 plus 28,000 equals $20,800. The value of the car after 3 years is $20,800. Sorry for that huge space in there. I know we put a little space, but that's a bit much. Okay, how much will the car be worth after 10 years? We're doing exactly the same thing, but we're just putting a 10 instead of a 3 this time. Don't really know why I'm doing this. Negative 2,400 times 10 plus $28,000. Negative 2,400 times 10 is negative 24,000 plus 28,000. And negative 24,000 plus 28,000 equals $4,000. It's only worth $4,000 after 10 years. When will the car be worthless, or will it ever? Well, I'll get to the will it ever in a second. But if something's worthless, how much is it worth? 0. It's a value, so you're going to put 0 into the v in the equation. 0 right there. So I'm putting 0 equals, what's the rest of the equation? Negative 2,400t, I don't know the t yet, so negative 2,400t plus 28,000. I have to solve that equation. I got to get the t by itself. Why don't we move this negative amount over and make it positive? So that'll give us 2,400t equals 28,000. I want to get t by itself. This is 2,400 times t. Why don't I do the opposite? Why don't I divide by 2,400 and divide by 2,400? That gets rid of those 2,400s because those cancel out. Just leaves you with 1t. Perfect. T equals, when you divide 28,000 by 2,400, you get 11.6 repeating. But why don't we round that? It can be completely worthless after 12 years. Okay, and then we could probably get into some kind of discussion about will it ever be worthless? Probably not. No matter how old the car is, there's probably some parts you can sell, or someone who wants to buy it for a couple $100. Probably some high school student who's never owned a car before will be willing to buy it. So it's probably never going to be worthless. But if we use the graph here and assume that it's just going to continue depreciating, it would be worthless after 12 years. Okay, next one's very similar. On his second test of the year, Dean got 46%. On the seventh test of the year, he got 58.5%. Assume that his rate of improvement continues for the entire year. That's a pretty huge assumption. It's almost for sure not true that he's going to continue improving for the whole year like that, but who knows? And if he does improve, probably not by the same amount either. It's kind of weird, but that's what we do sometimes in high school math. We make assumptions like that. So we're going to do the same sort of thing. We're going to graph it, find an equation, and answer some questions. Let's do it a little bit faster this time. So what values do we have? On his second test of the year, what are we graphing here? Quiz number and test score. So let's put quiz number down here, because that's kind of over time, right? And this is test score. And that's a percent. So on his second test, he got 46%. And on his seventh test, he got 58.5%. Here's our 2 points. And here, is he appreciating or depreciating his score? It's appreciating. So again, we could draw a line. Notice that we don't have a point right on the y-axis this time. So this question is just a tiny bit more difficult to find the y-intercept, but hardly more difficult at all. Again, you've got 2 points, so you can use 2 points and use this equation if you want, the change in y over change in x. But since I've already drawn the graph here, I might as well use the graph to find the equation. So to get the equation, we're going to use slope point, y minus y1 equals m x minus x1, and to use slope point, I need a point and I need a slope. Point. You got 2 points. It really doesn't matter which one you use. I'm going to stay away from the decimals, so I'm going to use this point. 2, 46. We need a slope. Well, to get the slope, I need to know what's the change in rise and what's the change in run between these 2 points. The change in rise is from 46 to 58.5. That's 12.5. The change in run is from 2 to 7. That's 5. So my slope is rise over run, which is 12.5 over 5, which is 2.5. Is that positive or negative? Positive slope there. And this time we're looking at percentage and quiz number. So it's 2.5% increase per test. Every quiz, he goes up 2.5%. Anyway, we got what we need. Y, take away the y value of our point, which is 46, equals the slope, which is 2.5, and then x, take away the x value, which is 2. Okay, that's point slope form. We're going to switch it into slope-intercept. So let's just take one extra step here. First thing we're going to do is we're going to do our mountains. So 2.5 times x equals 2.5x, and 2.5 times negative 2 is negative 5. Then I need to move my negative 46 over. So I get 2.5x, take away 5, but plus 46 when it comes over. So I get y equals 2.5x plus 41. That's my equation. Or we could change our y and x into things that might be a little bit easier to use. So we're talking about test score here. So why don't we put a t or an s here? How about a big T? T equals 2.5. Quiz number. Why don't we put a little n for number? Plus 41. I like that. That's a good equation right there. And then we're going to use that and just plug some stuff in. What score did Dean get on his first quiz? Well, that's when his n value is 1. So we just put 1 in there. T equals 2.5 times 1 plus 41. T equals 2.5 times 1 is 2.5 plus 41. T equals 43.5. Hey, his teacher gave half marks. Oh, wait a minute, it's percent, so not necessarily. Anyway, 43.5%. It's not a actual score, it's a percent. What score will Dean get on his 10th quiz? Again, we're using the same thing, but we're putting 10 in. I don't know what my fascination is, but the 10 in this worksheet. 2.5 times 10 plus 41 t equals 2.5 times 10 is 25 plus 41. T equals 66% he'd have on his 10th quiz. How many quizzes would Dean need to write before he received 100% on his quiz? So don't put 100 into n. That would be what his score is on his 100th quiz. We want to know when will he get a total score of 100. So you're going to put 100 into t. So 100, 2.5n plus 41. To get the n by itself, we need to subtract 41 from both sides. So we'll do that first. Subtract 41, subtract 41. That leaves us with 59 equals 2.5n. That's 2.5 times n. So we need to divide by 2.5 and divide by 2.5. Those cancel on this side. So you're left with n equals, that's 2.5. 59 divided by 2.5 equals 23.6. But you can't have 23.6 quizzes. He wouldn't actually hit 100%, and he'd have a little bit more than 100%, wouldn't he, once he got to his 24th quiz. That's the good news, getting over 100% on his 24th quiz. The bad news, I don't think, at least in my class, we're going to have 24 quizzes in any course. I usually give about 2 quizzes per chapter, sometimes 3. Only have 8 chapters. I usually don't know more than about 20 quizzes. I'm so sorry, Dean, you're not going to get there. Alright, I'm also so sorry to all of you for having to speak in this hush whisper the whole time. I can hear Simone stirring as I speak right now, so it's perfect timing. I'll go and tend to her. You go and tend to your wonderful linear applications. Alright, take care.
I don't think you trust in my self-righteous suicide. I cry when angels deserve to die.